Okay, so we're looking at checkpoint 2.4, problem number 1. The instructions say solve and check answers when appropriate. So I need to solve for x, and I am dealing with an equation here that has square roots in it. So I've got an x inside of my square root here. I've got an x alone over here. Since I've got an x trapped inside of the square root, I'm going to have to get this square root by itself on the left side of the equation, and then I'll be able to square both sides. So that's my game plan just to start. We'll see what that ends up turning into later. So I'm going to have to get rid of this positive 2. I'm going to subtract that over to the right side, and then we'll square both sides of the equation. So let's get some colors here to show my work. We are going to subtract 2 on the left side, subtract 2 on the right side, and that'll give me the square root of 4x minus 3 is equal to x minus 2. Now I'm going to square both sides. Let me make this one red. It'll be easier to click on later. I'm going to square both sides. Raise this to the power of 2. Get out of here. And then raise this to the power of 2 as well. So on the left side, the root and the exponent, this square root and this exponent, they're just going to cancel out. They're inverses of each other. So 4x minus 3 is equal to, on the right side, x minus 2 squared, I am going to have to handle that exponent. The way I'm going to do that is by writing the parentheses twice, and then we'll do some distributing afterwards. So x minus 2 squared is the same thing as x minus 2 times x minus 2. We'll do some foiling on the right side. 4x minus 3 is equal to x squared. So x times x is x squared. And then you would get a negative 2x for your inside and a negative 2x for your outside. So that's going to be a total of minus 4x, kind of skipping a step there and combining my like terms. Negative 2 times negative 2 is positive 4. Okay, I'm going to take a moment to look at where I've been and where I'm at. I used to have a square root equation. Got the square root by itself. I isolated the root, squared both sides, followed through on squaring both sides, and here I am. Now I've got a quadratic. I've got an x squared term, I've got some x terms, I've got some constant terms. So this is a quadratic, which means that I want everything on one side of the equation. I'm going to move everything over to the right side because that's where my x squared is already at. You could move things to the left side, but then you'd end up with a negative x squared, and you would still get to the right answer. I would just prefer to keep my x squared positive, so I'm going to move everything to the right. So I'm going to subtract 4x from the left side, subtract 4x from the right side. I'm also going to add 3 to the left side and add 3 to the right side, and we will follow through here. Let's just slide that down. Give me my pens. Okay, so the left side is now just 0. The right side is x squared minus 8x plus 7. Um, Whenever the left side ends up being empty, make sure you put your 0 there. Make sure you put your equal sign there. If you leave off your equal sign and you leave off your 0, then you might lose track of what you're doing and what the goal of the question is. The goal of the question is to solve the equation. So there should be an equal sign in every single step. Now I've got a quadratic, so I'm gonna need to factor this. It looks like I can just factor this with a -1 and a -7. So use whatever factoring technique works for you, whether that's the big X method or the AC method or um, box method. I don't know. There's lots of different like names for the different ways to factor. But x minus 1, x minus 7, that's how that's going to factor. You could refoil that just to double check. But what I'm looking for is I'm looking for numbers that multiply to give me positive 7, -1 and -7, that also add to give me -8. -1 and -7 multiply to give me positive 7, and they add to give me -8. So those are the factors. Now I can use my zero factor property. Since I have it factored equal to 0, I get to split it up and say that 0 is equal to x minus 1 as its own equation, and then also 0 is equal to x minus 7 as its own equation. And then we can solve each of these in one step. We get x equals 1 and x equals 7. I'm not going to circle my answer because I'm not sure that these are my final answers, unfortunately. So going back to the original, if you read the instructions, it says solve and check answers when appropriate. Anytime you're solving a square root equation, you're gonna have to plug in and check your answers. A lot of the time you get extraneous solutions and you didn't make any mistakes. It's just that this mathematical technique sometimes creates extra solutions that we have to keep an eye out for. So now I'm going to plug uh, these answers back into the original and make sure they actually balance. So 2 plus the square root of 4. I'm going to plug in my first answer of 1, and I'm plugging that into both the left side and the right side. I'll have to do some order of operations to evaluate this. You can use your calculator to help if you want to. 4 times 1 is 4, 4 minus 3 is 1, and the square root of 1 is 1. So we get 2 plus 1 equals 1, and then we get 3 equals 1. That doesn't make any sense. That means that this is an extraneous solution. So yeah, I got an unbalanced equation. I'm not going to keep this as my answer. X equals 7 is probably the only answer. I'm still going to plug in and verify. So 2 plus the square root of 4 times plugging in 7 for all of my x's, all of the x's on the left side and all of the x's on the right side. 4 times 7 is 28, minus 3 is 25, square root of 25 is 5, so we get 2 plus 5 equals 7, which is a balanced equation, so that means that x equals 7 is my only answer. If you submit x equals 1 and x equals 7 as your answers to this equation, you will not get full credit. So make sure you check for those extraneous solutions.